talk about that project on this one.
My future boss he graduated from our program like 4 or 5 years ago, and he took 641.
Okay.
Speaks about it very similarly to you.
Okay. Yeah. So it was Christian Murphy teaching that, or was that Ryan Johnson?
No, it was Christian Murphy.
Okay. Yeah, so I would say that class was probably the best. I mean, as long as I wouldn't try to take that class and like take a 16 credit semester. I think that with that class I only had 12 credits that semester. So.
And the next step is to define right now your initial program.
3 more IE classes and then a humanities class. So I think should be okay.
Yeah, for sure.
I kind of want to take it too. But if you say 16,
yeah, I mean it's doable. I know some students that did that took like 3 or 4 other classes along with that class. You just don't have much of a social life. It's a lot of work. Dedicated. I mean, just 16 credits in general is a lot of work in that class. They did ask a lot, like I said. So over here, you see the adjustments. This is basically just kind of, this dictates the feed rate. So you guys already had a feed rate in here. I'm not sure if you guys had a feed rate of something like 20 or whatever the case may be. But here, this is just going to be, this allows you to manually adjust the feed rate as you're machining, and all these are just going to be percentages. So like here, I originally started at like 80%, so 80% of 20 is going to be 16, feed rate of 16. Now I have it down to 60 just to make sure like we're still getting decent quality, we're still going fast enough. You want to be careful when like the tool enters the workpiece that you're operating a little bit slower feed rate just so it doesn't like get the workpiece and like grab something like it's a rough surface and then kind of like you might either, you'll see that on the lathe, sometimes it spits out the workpiece or coordinates don't exactly line up. But once you're actually in there machining like we are now, you can speed up a little bit and you kind of hear it going fast and you'll see it going faster. So this will just kind of turn down the cycle time so it produces the part a little bit quicker. So, and it should, with a feed rate of 20 and even a little bit less than that, it shouldn't sacrifice any quality or surface finishes. So it'll turn out okay.
I guess another thing I've been thinking about is how we take and generate these codes from FeatureCam in actual industry. What's common for how are these NC codes generated?
So yeah, I mean, there's FeatureCam. It's used. It's not necessarily used like industry wide, but software is like that.
Yeah.
And you have sort of CAD and things like that. So you have a lot of technologies and software similar to FeatureCam where you design. It's like your R&D. So you do the research and design. You design new products, and then you try to get new product development and production and things. So it's really kind of a similar process. I don't think FeatureCam is the most common tool used, but something very similar to that. I'm not, to answer your question, I'm not totally sure what the most common works. I think SolidWorks is common out there as well.
Right.
So it really kind of depends. Each company has their own tool that they use.
Because obviously you have your engineers, but you also have people just devoted to CNC.
Oh, right.
I mean, or that's their job.
Yeah, so programming can be done, typically it'll depend, your programming can be done kind of like by manufacturing engineers that actually understand the machines and the process and have the technical background like engineers do. And so sometimes if you have to do offline programming, they'll work hand in hand with R&D to like develop those programs for the CNC machines. But once things have been in production for a while, usually that responsibility can then be handed off to the operator, and they're usually trained enough to be able to do a little bit of programming. It just kind of depends on what company you look at. Like for instance, my last project at Morel, on their shop floor, most of their operators could handle the programming of all the products that were already going to the shop floor. But anytime something new was kind of brought to the shop floor, something new was released, the manufacturing engineers were kind of the ones that had the more expertise that they had to work with the more programming. So it just kind of depends. So we're on line 805. I think you guys look like you guys had 1,000. So we should finish up pretty quick. And then once we finish up, I'll make sure to slow down so you guys can at least get a feel for what it takes to load up the next part and get everything square so you have a chance to do it. That wasn't, so we'll see how your guys' turn out, but as you can see, depending on kind of the different features you define in the tool path, it just depends. So if you have a little bit too fast in the feed rate, it might come in on the finishing pass, and then it might try the tool try to pick up, and it might just take off a little bit of material. So I think it's going okay. I'll turn this down, so hopefully we can minimize that on your yours. But yeah, sometimes the scrap might pick up, and it just, it all depends. It's tough. So like this one, these turned out pretty good. So you might have the same program, you might run it 2 different times, and you know you might get 2 different results. But again, as long as it's within tolerance and things, that's kind of what you gotta do.
Yeah, so really, this is a training process, and for the most part, you don't have
So once this is done, I'll take it on and hand it over to you guys, and then I'll walk you through what it entails to go from start to finish for some of these in terms of loading the part, getting the coordinates defined and everything. So you guys can some practice with that.
So it is like a 6-axis, or?
So this won't be. So this obviously has your 3 linear, your X, your Y, and your Z, and then it has the 4th axis where the tool is rotating along the Z. But to my knowledge, it doesn't have a 5th axis where the cable rotates, or a 6th. So at least the programs that we've had don't even require a 5th and a 6th. So I don't know if it has that capability or not, but we don't use it. So now it's done. So what we'll do is these buttons over here. This is to open and close the door. This is to open and close the chuck, or the vise as they call it. So it's done, the door opened automatically, so we'll just open up this vise, we can take out the workpiece. Let's see if somebody wants, you guys can go around and take it out. And then just try to knock off the chips and just keep them in the machine. And then
basically, you just have to get back and that's what we do. So now I think from here you can see finish it.
So, yeah, so if you look at it, looks like we might have had a little bit fast feed here on the finish, but that's again not an issue. And this turned out pretty good, so that circle was really good. So yeah, next time if we can see like the finish pass go along here, we'll just turn the feed down to make sure that's smooth. But that turned out really good. So what we'll do is we'll load the workpiece and start the holder. And so what that all entails is we kind of have it detailed here on this. No problem. So this is kind of just your steps required to start machining a piece. So obviously first one being open the door, that's already open. So what we want to do is we actually want to load the workpiece. And so I'll put it in here for you guys just to make sure it lines up accordingly. And then we can let you guys kind of take over. I'll just get these chips out of the way so it doesn't.
They're really soft. The chips are
So we'll load this in here, make sure it's centered. And then when you want to just close the vise, so again it would be this one, just hit that, and you can see it close, and now it's in there pretty solid. So that's good.
How do you tell like how far, you know, because obviously it can alter,
Right.
you know, back and forth.
Yeah, so we've it's kind of just a setting within the machine, and so you just kind of put in the dimensions of your stock and just want to verify that, you know, you're closing it hard enough that you're going to hold the workpiece in there, but not too hard that it's going to chip, like I just showed you that one, right? Where it gets too hard and then it just chips away. So now that we have that loaded, what we want to do is kind of just follow these instructions. What we want to do is we actually want to, this is where the offset comes in, so you guys might have seen this in Feature Cam a little bit where it asks for your X, your Y, and your Z offset. That's kind of what we're going to define here. So you'll notice that when we start each workpiece, when you load it in, you might not load it exactly the same. You know, you might have the workpiece a little bit to the center, a little bit to the right or the left, so it's not always the same every single time. So basically what we want to do is to make sure you're still getting the same results that you want and that Feature Cam said you would. You want to make sure you're starting from the origin and the coordinates line up. So that's what we're going to do now is just kind of bring the tool down to the workpiece in the front left corner where you guys started the program in Feature Cam to make sure all the coordinates lined up. So what we're going to do that is we're going to use the jog feature, and you guys can do this too. If you just want to bring, I'll start and then I'll let you guys kind of finalize it. But what we want to do is bring the tool basically to where it's almost touching the bottom left corner of the workpiece. We want to write down those coordinates to make sure we remember what those are. Put those in the offset so the machine recognizes that as our new origin, and then we can start the machining after that. So I'll just bring this down and you'll kind of see how we can move this stuff around. Yeah, those, I would be lost without those. Alright, so it's close enough. If you guys want, I'll turn it down just so we don't do anything wrong. But if you guys want to, if you want to have one of you kind of standing over here to watch the X, you kind of want to make sure the left side is kind of right in the middle of the workpiece. I can watch the Y, and then if you just kind of want to watch the Z. So you can probably do the Z last, just to make sure that we don't go into the workpiece. So how does it look in the X?
You want to move a little bit this way.
So I can go past that. Oh yeah, Y is gotta go back a little bit. Is that right?
No, just a little bit more. Okay, that's about a little
Then you can bring the Z down a little bit, so I'm a little bit closer. You can keep going.
You're actually,
A little bit more. That's fine.
okay.
How's the X?
Can't like it changes. Yeah, you're pretty good. You're actually, it looks like your center, your drill bit is right on the corners.
Okay, yeah, that should be enough.
So,
And then you probably want to, just to make sure we're okay, you're probably going to want to, you can do a little bit of plus Y.
you're just gonna orient
Maybe a little bit more.
It's a rough pass, but
So the tool's hanging over a little bit. Maybe bring minus X just a little bit, just to make sure we're getting the corners. Maybe a little bit more. That should be good. Does that look alright from?
Yeah,
Okay.
that looks good.
And then
Better.
I think the Z, you can probably bring the Z down just a little bit.
And then a little bit more.
Let's see. The true test is a sheet of paper, so we'll see. Let's see if this works. So I think you got a little bit clearance. You go down a little bit more.
Yeah.
Yeah, just touch it, bring it up a second.
Bring it up.
Yeah, just touch it once, yeah, that's good. Okay, so now that defines our ordinance, what we want to do is, when you want to write this down, you want to write these numbers down, because this is what the machine thinks it's at, but we want to tell the machine this actually should be 0, 0, 0.
Okay.
So write those three numbers down.
no, it's not really.
Okay, and now we're going to enter those into what we would call offset. So what we're going to do is enter it into here. So if somebody wants to tell me what those numbers were.
5.5839,
39, okay.
0.6250, and 5.6453.
Okay. Okay, so now those are entered in, so if we go back to position, you'll see this is 0, 0, 0. So we told the machine that's what we want to be our 0. Now what we have to do is we got to load up the next program to make sure we're running the right thing. So the next one we